Hey guys, can you hear me?
Hello, I can hear you.
Hey, how are you?
Yeah.
Recording in progress.
Awesome. Do we start or do we wait a little bit more?
Okay, let's start now. Okay, it's 2 o'clock. Welcome, Gorbunov. I'm Yunhe. Okay, let's start. Hello, everyone. Welcome to this Sunday's cross-chain open class. I'm today's host, Yunhe. Before the guest speech, I will give a brief overview of our Whaler in the public open class. Whaler is committed to building a decentralized, autonomous organization that combines sense popularization and publicity, investment, and research. We want to build a decentralized governance framework for the community around people and organizations. And in the future, we will form a business closed loop of open governance, media publicity, and product support. So more people are welcome to join us to build together. At the third public open class of Whaler's same line, Whaler's cross-chain open class, our goal is to link more college students with science and technology, bring more fresh blood into the Web3 industry, and get everyone to do a good job of gene security control. During the whole course organization process, we got support from many enterprises and people, especially the help provided by PKU Chain Association, My Protocol, Tenor-Tree, as well as the support from more than 50 colleges and DAO organizations. Special thanks to the White Road Data for providing public welfare sponsorship. And now for our main event of the day, we have invited the Axelar CEO to speak Turing-complete course and messages. Axelar is a blockchain interoperability platform designed to connect different blockchain networks and enable seamless communication and transfer of assets across them. It aims to address the issue of blockchain fragmentation by providing a decentralized network that acts as a bridge between different blockchains. Axelar's vision is to create a seamless and interconnected blockchain ecosystem where different networks can communicate and collaborate, fostering innovation and expanding the capabilities of blockchain technology. And welcome to the WhalerDAO's cross-chain public course on Sunday. And we are honored to have invited Gorbunov, the CEO of Axelar, to give a special shine and look forward to your interaction. Okay, it's your turn.
Sounds good. Well, great to be here. Could you let me share my screen? It says host disable screen sharing. I still cannot share my screen. It still says host disable screen sharing. Yes, can you hear me?
Oh, you can't use the screen sharing?
I was not able to. Let me try now.
Do you have prepared your presentation, PPT?
Okay, I think I can share now, so let me try this.
Okay.
Can you see now?
Okay, I could see. Yeah, I could see now.
Okay, perfect. Awesome.
Okay.
Awesome, sounds good. So yeah, let me give you kind of a quick overview of Axelar, right? And some of the thinking behind the network. So if you take a step back, right, I think many people have made the analogies that blockchains are really cities, right? They're kind of open, permissionless, they're decentralized, and they need to be robust, right? So no matter what happens to your blockchain, whether or not you have, some of the nodes going down or electricity going down, you should have sufficient decentralization around your blockchain to make sure it keeps them running, right? The question, though, as we have many of these blockchains being built, is that how do you build an application across all of them at the same time, right? So suppose you're building, a decentralized exchange. Where should you put that exchange? Right? How do you allow it to operate across all the different chains at the same time? That's, of course, a very hard question, right? Until recently, really, we only had two different options to connect these different blockchains together. So one was to kind of trust a lot of centralized providers, right? Like centralized exchanges. And centralized bridges, exchanges, kind of apps, they're all examples of really cross-chain applications because they do actions across different tokens, but you assume some type of a trust in between them, right? So there is often an intermediary that takes, possession of assets, and you trust in them to kind of operate in the right way. So that has been option number one. Right? And option number two has been really to allow to offer what I call. Right? So in other words, if you're a developer, you can take your application, you can put it on top of every different chain, and then you let the users figure out how to interact with it. Right. So and then as a user, you think about, how do I pay gas across every different chain? How do I, is it the same application? Is it a different application? Do I bridge my tokens back and forth? Is it the same token? Is it a different token? So very, very painful experience for the users and developers at the end of the day with this paradigm. And so today you can do better. So today you can build what we call as Interchain-Native applications. Interchain-Native applications have the following properties. Level, they're supposed to span all of Web3, right? So all of different blockchains, layer ones, layer twos, they need to operate on top of all of them from the get-go. They need to be powered by decentralized interoperability, right? So if you have decentralized protocols powering decentralized blockchain, everything can continue to function in a very robust and composable way. And so composition really across these chains is something we're trying to preserve, right? So being able to interact from one ecosystem to the other or compose your application of contracts is very, very critical. And finally, the goal is to be able to simplify user experiences, right? So from a user perspective, being able to interact with all of these different instances of the application is very critical. So if you've never played with an Interchain-Native application, I think one good example is the Squid application built actually on top of Axelar. So I'll tell you in a second a little bit more about how it works, but what it does is very, very simple. It allows you to swap a token from one chain into a token on another chain in a fully decentralized and trustless way. So what do I mean by that? It means that it actually composes different decentralized exchanges through the Axelar protocol, and I'll tell you about that in just a second. But I encourage you to play with it quickly. Maybe I'll do a quick demo at the end of this if we have some time. Very, very simple custodian in the middle as you're using it. And so the way that this Squid protocol actually works is, as I just mentioned, it kind of composes decentralized exchanges on top of different blockchains. So this is like an example. Let's say you have, Polygon, and you want to swap some tokens for on Moonbeam. You have some decentralized exchanges on Polygon between native assets on Polygon with USDC, right? And so what happens is you call in this application is, if let's say you want to swap a token like like a MAG from Polygon to a token on Moonbeam like Glimmer, you can swap this token into USDC. You can route USDC through the Axelar protocol, and then you can call another decentralized exchange on the receiving end to swap this USDC for the token at the destination, right? And this last step is usually done just by calling a decentralized exchange and the parent between the native asset there and the token that the user wishes to obtain. So very, very simple application. You don't have to create any kind of a wrapped assets. In the protocol, it's very, very simple. You're leveraging the existing decentralized exchanges with the deepest pools of liquidity to actually perform the functions, right? But from a user perspective, at the end of the day, it's this ability to interact with dozens or hundreds of different chains with thousands of different assets and efficient one-click experience. So very, very powerful. So this is at the end of the day what Squid does for you, right? And I encourage you to go and play with it. You can do cross-chain swaps. You can compose existing decentralized exchanges. It will span across dozens of different chains. And very importantly, it actually takes very minimal security risk, right, on the underlying bridge provider. I think we have all seen various like bridge hacks and so on and so forth. But with the Interchain-Native applications, you can actually design something a lot better, something that does not assume a lot of risk from the underlying bridges. And why? Is because, like I said in the above protocol, you always start and end with the native assets, right? So you never have to hold any wrapped assets in a process. There are some wrapped assets underneath the hood that are doing some intermediate functions, but you always end up with your native assets, right? And so you don't have situations like, we recently seen with like a, multi-chain hack where, a lot of liquidity has been stolen because users hold these kind of a wrapped assets. With the Squid protocol, you don't have that problem, and you always hold your native assets no matter what happens with the underlying bridge provider or the source chain to begin with. So that's really, really powerful, right? And so that's the kind of the end game of the Interchain, right? Is being able to design an application that has very simple user experience, allows it to interact with different assets across multiple chains, and compose applications with one another across ecosystems in the same way as we can compose them on the same chain. Okay, so that's the goal. So how do we build this? And I'll tell you kind of for the remainder of the talk a little bit about what we do at Axelar to build this, and some of the design principles and some of the architectures behind the protocol. And so to do that, we always start with the end goal. And the end goal for us from the beginning has been to allow users to interact with any asset on any application, any chain with one click. Okay. And so to do that, we have to reverse engineer it and figure out what are the pieces of the stack that are actually missing to enable this completely. And so from the very beginning, the Axelar was designed for developers in order to allow them to build these types of applications. Right? If you look at the earliest white paper that we wrote a couple of years ago, it was titled as Connecting Applications with Blockchain Systems, right? We're not talking about building pairwise bridges or bespoke connections. We're really talking about building a developer framework that allows this Interchain-Native application build out, and we have to, reverse engineer that and figure out how to do that efficiently. And so today, the Axelar network is working with a lot of leading projects in the ecosystem. Circle, Uniswap announced their study recently, Osmosis, Ledger, Pangolin, Binance, SmartChain, and so on and so forth, and the list continues. So we have connected over 40 different networks across the stack, processed over 2 billion in cross-chain volume. Hundreds of thousands of cross-chain requests have been served, and like kind of lots of applications are built in on top of the network itself. So this is what the Axelar network kind of is right today. And so let's take a step back and try to see how do we actually build Interchain, and how do we build the interoperability protocols, right? I'm sure you guys know that this topic has been around back and forth across many different projects. And for us, it has been very, very simple, right? Connecting blockchains is like connecting networks, okay? And connecting networks is not something that is a recent topic of conversations. This is something that, has been in the studies in academia, in science, in the internet for dozens of years, right? Since 1960s, 1970s, where some of the early research has been. And so as we're building Axelar, we went back to the first principles and try to understand what are the properties that you need to provide to make sure that you have reliable and secure environment. And so the early works about communication on the networks actually goes back to 1974, right? And if you're familiar with the internet, right, then there is a famous protocols like TCP/IP or IP in particular that allow us to communicate on the internet. So we'll go back and try to understand what are the properties that those protocols provided that allow them to scale to today's internet and connect millions of different networks together. And so I'll review some of these properties, and what we have done is we took those properties and sort of adopted them, and we try to see what they mean for the context of blockchains to make sure that we can have these, robust connectivity properties. And so the first principle for us has been very, very simple, is that we want to be able to integrate any network, any blockchain network, with no changes to it. Okay, so meaning that maybe you have a layer 1, maybe you have a layer 2, you have a zero knowledge layer, you have your custom consensus or smart contract rules. We want to be able to plug and play to it, right? In the same way as you have like a USB adapter, you can plug it in any laptop, right? You're not requiring any changes from the laptop or the USB itself. You can just go and plug and play. We want to have the same type of a plug and play connectivity to interoperate across networks, right? We don't want to be in a situation where a network has to go and design or modify its consensus protocols to be able to interoperate. That would introduce a very significant barrier to innovation. So that has been the first property that we wanted. The second property that we wanted is what we call is very, very robust packet relay, right? So relaying across different blockchains is a kind of a physical process, right? You have one network, you have another network, you have to take a packet from one network and you have to be able to post it on the destination network, right? And if you have many of these networks, then relaying becomes even more complex, right? You go from A to B to C to D and so on and so forth. And so permissionlessly relaying packets across this network is actually something very critical to allow for the robustness that we're looking for. So the third property that is important to have is what we call as a gateway-based connectivity, right? When I say gateway-based connectivity, essentially what that means is that on every chain that wants to connect with the Axelar and its interoperability stack, we want to only be able to deploy a smart contract. The smart contract is what we call a gateway, and then all of the information can travel from that blockchain to the smart contract, be understood by the Axelar interoperability protocol, and relayed to all the other blockchains, right? So this is what's known as a gateway-based connectivity. And kind of the simplest analogy is like how you connect into the internet today, again, right? So at home or, you often may have kind of a modem or router, right? So, and if your laptop is connected to a local wireless network, then your packets will go from the laptop to this router, which is a gateway, and then underlying like internet infrastructure will take those packets and then deliver them to the destination, to a destination network itself, right? So that's what's known as kind of a gateway-based connectivity. And the same philosophy. So the fourth property is decentralized blockchain. So blockchain is really robust, everything about interoperability. So continue to be decentralized. So fail that situations like this being the percentage from all of the actors. If multi-chain is an example where centralized control leads to liability, leads to taking risk of these people. And the only way we can make sure they remain robust is to learn to decentralization. And then the final property that I mentioned that we of course need is the property of cross-chain safety. So if you design a protocol that you have to go through blockchains, then you want to make sure that your transaction destination is accepted if you look at it's finalized in this chain, right? So that's pretty trivial, right? You send in a token, you want to make sure this token is accepted by the source chain network and then accepted in the destination chain. Awesome. So now that we kind of understood all those different properties that are required, the other thing that I've done is kind of take a step back and see what are the layers that we can build into provide to make sure that these properties can be correctly instantiated. Right? You don't want to mix them together. You end up with very, very complex moving code. You want to be able to layer them one on top of the other and be able to upgrade them independently. So this is why we define this framework interoperability layers. At the top, you have message semantics, which is a very simple API that is exposed to the developers and will use this API to make all of this works. And then below it, you have the mediation and transport layer, nation layer, which is responsible for establishing trust with the blockchains. And the transport layer is responsible for delivering packets and actual relay blockchain. And so it's critical to keep these properties decoupled so you can keep on upgrading the things that are critical people like the validation of transport layer, but to keep the API implementation very, very simple, very, very consistent. So that's what we call message semantics API. Across this layer, just to give you a sense of what they mean and the fact of the actual itself, and tell you a little bit about them. So at the top of the interoperability semantics, we have message semantics, right? So message semantics is a way to call a message from one blockchain to another, and it's a very, very simple API. It's a header of your hello, and that header you specify destination chain, you specify contract, you specify the message that you want, for instance, your payload. So the source, our contract, the gateway has this function exposed to it. The message will arrive locally at the destination blockchain, where it can be subsequently executed and subsumed by the application. So this is very, very simple. I would go below the layer of the stack, validation layer. So validation, as we described earlier, is something that allows us to validate blockchain. There's really two methods of validation. Everything else is kind of multi-categorized. What I call quality validation. Basically, the idea is that you have two blockchains. They can understand one another, so they speak the same language. And so it's easy for one blockchain to interpret the messages that are posted on another chain. So example, this was an IBC protocol, where IBC protocol allows us to act very, very native to one another. So any Cosmos blockchain can take a message, and that message has been interpreted at a destination chain and subsequently verified. So that's an example of being very much different. be able to validate messages between two blockchains, where the blockchains don't necessarily speak the same language, right? So, you speak one language, I speak another language. We want to be able to translate packets in the middle or validate them efficiently. And so the question is, when you have this verifier logic, is that how decentralized can you make it, right? If it's one server, then you go back to the centralized exchange regime. If it's fully decentralized, then we're actually just introducing another blockchain application. So that's what we want to decide. And so the final layer of the interoperability is what I mentioned, is sort of the transport layer, right? And sort of it's responsible for cross-chain liveness and communication model, right? One thing it needs to do is to instantiate the relayer model. And like I said, you want to make sure in most systems that relayers are as permissionless as possible, so anybody can actually post a packet, and it gives you a robust system. And you're talking about the topology, right? How are the networks connected with one another? Do you have a point-to-point topology where every network needs to talk to every other network to achieve full connectivity? Or do you have a hub-and-spoke model, right, where most networks speak to a hub, and then information can travel from the hub efficiently? And so it's clear that the topology affects the cost of integrations, right, for all of us. So if we're in the peer-to-peer topology, then connecting everything together, you'll be required to do, n squared divided by 2 number of connections, right? Versus in hub and spoke, everybody just needs one connection, connect to the hub. So a lot more efficient and a lot more cost effective. And so, in practice, point-to-point topologies don't scale really well, right? We have seen that through the internet that ended up being a very, very hybrid network, right? Where we have these major hubs of connectivity, and they, from there you branch out and connect a lot of different other networks, and they're all, connected and exchange information with one another efficiently. But it's not a complete graph of full connectivity, because that would be, enormous number of connections, which we could not handle, and it will be very, very cost prohibitive. So if we are in the model where the hubs are going to be inevitable as we scale, then, like I said earlier, you want to make sure that these intermediary actors are as decentralized as possible, right? Or the hubs that you go through as decentralized as possible. And this has been really some of the design principles behind Axelar, is to be a hub, right, in this hub and spoke model, and be decentralized interoperability provider that all the other networks can safely rely on.
Yeah.
Sir, was there a question? Or?
Yeah, any audience, do you have any questions? Thanks for Gorbunov, very full, shy.
Awesome. Should I keep going, or?
Yeah. Do you have finished?
No, I still have some slides.
Oh, okay.
Awesome. Yeah, no, sounds good. I just thought there was some questions from the audience, so I just took a quick pause. So if we go back to mapping, interoperability layers to these properties, then, on the very top, we have the message semantics, which is, the property that I talked about earlier, where, no changes should be required to integrate. They should be instantiated via gateway-based connectivity. Below it, you have validation and transport that's responsible for, safety and relay of the packets. Okay? And decentralization has to be, across all the layers, like I described earlier. And so, if you look at interoperability solutions today, I think there's really like 4 buckets you could describe. There is, of course, IBC, which is across Cosmos. And so you have, channel-based message semantics. Its validation relies on light clients and supports, Tendermint consensus quite well. And it has a permissionless relay with a point-to-point communication, right? And then you have, other solution spectrums like Wormhole or Layer 0 that also has gateway-based connectivity. but a pretty centralized protocols, right? So especially, wormholes like 11 out of 19, validators that need to validate the message. Layer 0 does not offer validation at all. And so, you have to go and find your own validation layer or rely on their default, which is just 2 out of 3 multi-sig, right? And so Axelar, in contrast, offers a gateway-based connectivity. It's a full decentralized proof-of-stake network, and it has a permissionless relay in a hub-and-spoke model. So that's the kind of a high-level, description of the Axelar. So now let's go back to the actual, Axelar network itself. Let me give you a little bit more of what it offers in some sets. So in one, what we have done with Axelar is really have built a full stack of interoperability, right? So there's the Axelar network itself. It's responsible for, cross-chain connections, routing, and translation of packets. You have various services on top of the network that's responsible for, relaying of packets, things like gas services. And then all of that is put behind very simple SDKs and APIs that developers access, right? And developers only interact with those SDKs and APIs, and kind of all the complexity of the layers underneath it is hidden from their view. And so all these properties that I talked about earlier, you don't actually have to think about them as a developer, right? Everything is, much simpler for you. So how does Axelar work, right? Let me talk a little bit about connectivity. So at the connectivity, we support multiple connectivity protocols, right? So there are things like IBC that are native to the core, and if you have a chain that speaks IBC, great, you can plug that into the Axelar protocol, right? For EVM chains, there is its own protocol called cross-chain gateway protocol. It's a one-to-many network, right? So meaning that anytime you make a connection to the Axelar, your connection can automatically talk to networks, right? It's not a pairwise connectivity. And you can do everything from asset transfer to message passing, right? So you can send your favorite NFT, you can take a loan against chains, you can compose your contracts, like I said earlier, in a fully decentralized way. Is that it can do the translation across different software stacks. So as an example, we have recently rolled out an upgrade that allows kind of Cosmos chains to interoperate with EVM chains, right? So in Cosmos, you have like ribbon consensus, you speak IBC, you most likely will, using some type of a Rust environment to code your application. And on EVM side, you have Solidity, right? Very different format of messages, very different format of applications. And so through the Axelar protocol, we can actually connect these things, together and allow talk with smart contracts on, Ethereum or Polkadot and vice versa, right? So these chains can interoperate with one another. So to actually use the network, you can download the SDK. There is a simple NPM package. And then you can use the general message passing of applications. You can send assets across them. You can compose your, DApps, or you can issue interchain tokens or anything else that you want. It's a really Turing-complete environment in that sense. Now, one of the challenges that we have been facing, I think, not as Axelar, but as a whole ecosystem, is that the number of chains and different layers keeps on growing really, really rapidly. Right. And so, by now, I'm very proud of all the different networks that we have connected. Like I said, connect over 40 networks to the stack, but the number of requests for more connectivity keeps on coming, and we're doing our best to keep up with them. And so what do we do about it, right? And the second problem that I think continues to happen is that the deployments across these environments are becoming more and more complicated. 80% of their time kind of deploying the applications in the multi-chain environments versus actually building application logic, right? And this is something which we don't want to do, right? We don't want a developer to write some 100 lines of code and then spend 80% of their time deploying it on different chain and figuring their smart contracts, figuring out kind of governance protocol. We want all of that to be automated. We want all of that to be much simpler, so developers can spend 80% of their time actually improving their code, and only 20 or 30% of their time, thinking about the deployment of those things. And so the interchain infrastructure needs to have more connections, it needs to have more composability, and it needs to have much simpler developer environments for us to unlock all of the use cases that I talked about earlier. And so one of the very exciting things that we're going to be doing to address these things at Axelar is introducing a virtual machine, right? And a virtual machine is going to be a Turing-complete environment. It's going to be completely programmable, and it's going to be instantiated on top of the Axelar network to allow Interchain to scale. What we'll be able to do with it, I'll tell you in a second, but on a high level, you'll be able to instantiate new connections, you'll be able to optimize the speed of transport layer, or you can even build some interesting application at the interoperability layer itself, like a name and service. And so the virtual machine is there to really allow us to scale the interchain 10 times faster. Right? So where's the number 10 come from? Well, we can actually prove it that we'll be able to scale interchain 10 times faster. I'm just kidding. We're not going to be proving anything. This is an arbitrary parameter, but trust me, because we have programmability, we'll be able to achieve kind of a connectivity at a much safer and much faster speed than we used to be before. And so, what are some of the examples of kind of products that leverage the Axelar virtual machine? So the first example of the product is going to be called Interchain-Amplifier, and that's basically a service, a permissionless service, for you to be able to add a new connection to the Axelar network, right? Meaning that you'll be able to customize security of your connection. So you can use external validation, you can use light clients, you can use zero knowledge proofs, you can use really anything, right? And why it's called an amplifier is because you get to amplify your work, right? So remember earlier I said that if you were building a lot of connections, you have to spend a lot of resources doing them. But by connecting to the Axelar protocol, at the cost of building one connection, you get access to n different chains, right? So all the chains that have been supported through the Axelar stack, you automatically can interact with just by building one single connection. And so this is really the goal of this, allow interoperability to be kind of a timeless, right? So you can build as many connections as you want. You can customize the security of these connections. So you can have RPC-based logic, you can have zero-knowledge-based or light client-based connection. You can compose them together, right, to provide even stronger security. So you can say, only needs to be authorized if 2 out of 3 of these connections authorize my packet, right? So you get to design very, very simple, security model underneath the hood. And so this is the goal. This is the end state of connectivity, is that the connectivity can sort of evolve. The application interfaces remain the same for the developers, right? So if you code today, your application, you know that as more chains are added, you can continue using the same API. You won't have to migrate to a new API, but the security and the number of connections that you'll be able to tap into it will keep on growing and growing. So the other project that I'll mention that we'll be building using the Axelar virtual machine is called Interchain-Maestro, right? And this is something I'm super excited about because it allows us to build a set of template contracts that you can use to manage your application across different chains, right? So the basic, simple way to think about it is that you can think of it as a kind of a Kubernetes for Web3, right? So Kubernetes allows you to compose multiple, application pieces together in one environment. So you can run your application code across, a server, an archive node or database, an application server, and have it all reliably being executed. And so in the same way, you'll be able to use Kubernetes to deploy your application code to many chains with very, very simple experiences and interactions. So let me give you kind of a high-level preview of how this interchain, master would work. So and type in the address, and as soon as it's loaded, you can see that the contract is deployed on Avalanche, and the same contract has already been deployed on Polygon or Binance Smart Chain, right, by this interchain, service previously. If you want to deploy this contract on other chains for your token, then you can, click on deploy more chains. You specify which chains you want to run it on, so any number of chains, and that's it. You hit deploy, right? And you pay gas once. And what happens under the hood is that your contract gets mirrored on top of other chains. It gets instantiated with cross-chain support automatically, right? So you'll be able to send those tokens back and forth. You'll be able to include them in the applications and interact with them very efficiently. So as you can see in this example, very, very easy to deploy across multiple chains. Your interchain token, you didn't have to write any code. You didn't have to glue anything through the relay logic. So everything is simple. Everything is automated through this simple front-end interface. And so that's it. You can see it's now been executed on top of two chains. Awesome. So this is really the impact of kind of a programmability at the interoperability layer, right? That's why we added the virtual machine, is that you'll be able to build many more connections. You can fully customize those connections. So instantiate them with any type of security guarantee, kind of light client, zero knowledge proofs and so on and so forth. And as a developer, you'll have minimal work to run your application across multiple chains without having to deploy it one after the other, in many different times. And so we have a lot of partners that are, already connected today with the, with the new service, right? The previous service, I already said we connect to like 45 different chains, but there's a new wave of partners like Stellar, the Basecoin, by Coinbase, Mobile Coin, Near, ZK Sync, Starknet, Shardum. All of these guys are going to be leveraging the services that I just described for the next iteration of interoperability. And so finally, I just want to mention that there's a lot of ways to get involved with Axelar, right? So you can go to axelar.network. There's a lot of funding opportunities that we have. There's a lot of blog posts that we wrote that you can read and kind of learn more about it. So I highly encourage everybody to, check it out and, play with the network, learn the tools, learn the framework, and learn how to build Interchain. So that's it on the main presentation. I did want to kind of share one more screen and show you a little bit about the Axelar scan, which is one of the explorers that you can top of the network to understand how it's functioning, right, and understand what it is. So if you go to axelarscan.io, you'll see an explorer on top of the network, and you can see all the different chains that are connected, right? So everything from Binance, Avalanche, Terra, Polygon, Ethereum, of course, most chains. And this is really one of the most advanced, I think, interchain explorers. So you can go to understand, how much traffic the network is producing, what are the types of packets that are being sent, how long they take, right? So, some of them are executed in like 27 seconds, 16 seconds. Full finality sometimes take longer. You can understand which contracts talk to which other contracts across different chains. There's a lot of intelligence, a lot of, analytics. And you can understand who secures the network, right? So if you click on the validator tab, there's a lot of validators that are running here. It's a fully permissionless way to join the validator set, right? So anybody can join, anybody can participate to be a validator in this model, and you can learn a lot of information about what they do, which networks they support, and so on and so forth. There's just in general a lot of good information. Like I said, I think it's one of the most, advanced can go to resources and things like that. And then the other place that I'll just mention for you to check out is docs.axelar.dev, because this is a good place to get started if you want to build on top of Axelar. There's introduction on top of the network. There's links to the SDK, local developer environments, being able to send tokens. If you want to spin up a validator, there are instructions there. But this is a very good place to start, and so I encourage you to check it out as well and play with the code. We have Discord, so you can go to Discord and kind of ask any questions if you have anything. You can find the link here, and follow the project on Twitter, Telegram, and things like that. Awesome. So I think I'm done with my main presentations. If there are any questions, I'm happy to go deeper into them.
Gorbunov, have you finished your sharing?
Yes, I have finished.
Yeah. Okay, audience, do you have any questions? You can interact with the chat with the Gorbunov directly. Okay, question to ask you first, and I will in the chat box. You can see in the right side on your screen. Could you see it? Can Axelar's API be used in real-world applications, and how does it handle high throughput and large-scale transactions? Is my question. Yeah.
Right. I mean, real-world applications, yes. There's a lot of applications that are ready, Axelar, right? That are, leveraging the protocol. I'll drop a link here. You can take a look at, some examples of the applications that are, or partners that are leveraging the Axelar protocol today. So that's number one. How does it handle high throughput and large scale transactions? Well, network is based on very fast consensus, right? So it leverages Cosmos Tendermint consensus in order to finalize transactions, and you can process thousands of transactions per second using that consensus. There's a lot of batching and optimization techniques that we have been building on top of the network as well, so you can batch transactions efficiently if you have a lot of traffic. So yeah, we're kind of pretty confident we'll be able to kind of support all the needs that are there for the cross chain.
Okay, thanks a lot, and I can see your link. And I have another question. Okay.
Good.
Yeah.
Awesome.
Native cryptocurrency in the ecosystem, and how to get and use it. Yeah.
Yep. No, great question. So it's AXL is a little bit more, but the Axelar is a decentralized blockchain, right? And so it's powered by proof of stake token, AXL, which is responsible for incentives on the network, right? So token holders stake with validators. Validators run the decentralized consensus, and for processing cross-chain messages, rewards are distributed back to the token holders, right, and the validators. So you can use the token to participate in governance. You can use the token to stake, to help secure the network. And I think those are kind of some of the example use cases.
Okay, thanks. We have the last question of everyone. Do you have any question? I see a new audience coming. So okay. And I have the last one. The third question is, how is Axelar's performance and scalability? How does it handle high throughput and large scale transactions?
Yeah, I mean, similar to what I said earlier, right? Because the network is based on proof of stake consensus, we're able to process, thousands of transactions per second, right? And be able to do it efficiently. And there's a lot of batching techniques that are built in the consensus to handle very high throughput and, large transactions as a result.
Okay. It's all my questions. If other people have no questions, our open class it will be finished now. And thanks, Gorbunov, for your prepared so rich content. And thank you so much. Okay.
Awesome. No worries. Thanks for having me. Bye.
Bye. Bye.